Okay, so this is an example table. Kind of, I don't want to say perfect because I feel like I'm setting myself up for a fall if I do that. But it's the table I'd be expecting, something along these lines for your pendulum experiment. So this is just to be clear. This is the experiment. You've got a pendulum. You're going to count the number of, you're going to count 20 oscillations and you're going to time 20 oscillations. Bearing in mind that an oscillation is all the way through from the centre, so through the centre, back to the centre. That's one oscillation. I know you can start anywhere, but doing it from the centre is the easiest point to see where it's very specifically at a certain point at a certain time. So it's also through the centre all the way and back, not 1, 2, 3, 4. Right? It's firstly, when you start your stop clock, don't go and 1. It's 0, 1, 2, 3. Okay. Again, there's videos if you've sort of coming to this afterwards, there's videos you can watch if you can't set a pendulum up, but to be honest, it's dead easy to set one up if you can find the string. So set one up and record some of your own data. The point is that you're basically going to have different lengths of pendulum and you're going to record the time for 20 oscillations. Okay, you're going to do that twice, potentially more, but I've given you videos that only do it twice, so that's okay. And ultimately then we'd work out a value for t. So I'm going to take you through what I'd be expecting your results table to kind of look like. So, I'm going to put length in this table, but I'm still going to put the trial numbers in because that might make it a little bit easier when I'm referencing things that I might have to calculate as a result of this or errors later on. So, I'm still going to have my trial number. Right, I'm then going to have 2 columns where I'm recording the time for 20 oscillations. So, don't write period, because it is not period. You're not recording the period, you're recording 20 periods. So you could say time for. Now as we're doing this twice, it's kind of acceptable to have a heading that goes right the way across. If I could sort of do a fancy merge thing on this, I would, but we'll just have to pretend that I've got a line across there and that line in the middle isn't there. Time for 20 oscillations. Now I like in results tables, this is just my personal, I like things to be nice and simple, so in terms of a nice defined symbol. So actually, whilst it's perfectly acceptable to write that, because it's clear, provided I've defined what I need it to be later on, I quite like writing something like 20t, 20 oscillations. Or you could just write t. Whereas somewhere else you have defined what t is, as in t is the time for 20 oscillations. Lowercase t, because capital T is the period. So we could have, for example, t1, t2 for our 2 repeat readings. So t is time for 20 oscillations. Okay, so I'm just going to do headings first. So now this one is optional, all right? You've got 2 repeat readings. For the sake of some of the error calculations, which is, we're not going to worry about error calculations for this, having a mean t, okay, might come in handy, but it's not 100% necessary. What's the important bit, is that I've got t, which is the time period, okay? If you do write the t in words, I've written t-bar, which is perfectly acceptable notation. You write it in words, make sure you use the word mean, not average. It's a mean. Average, there's lots of different averages. We always use the mean for repeat reading, so make sure it's mean. Okay, so then we've got the t for the time period, capital T. And you could record the length somewhere else, so we could have another table with trial numbers, 1, 2, 3, 4, and lengths, and you just record the lengths. And then we would know, if we got trial number 1 there, that length 1 goes with all the times 1. But I'm going to make life a little bit easier for myself and not do that. I'm going to put length here. Okay, so I've got the quantities in, so that's the first thing. The second thing, I want some units, and the third thing, I want some errors. Now, as T1 and T2 are both time, they're both timing the same things. Again, you could have all this in one heading that went across the top of both of them, and then just have lots of repeat readings underneath it, that's absolutely fine. So a little bit like the example right at the beginning, like this, where the heading is all the way across the top there for time, and it's just split into 5, where you've taken 5 different repeat readings. So something like that's perfectly fine. I'm only actually writing it like this because that's the way I can put a table into OneNote, if I'm honest. So then, if we look back at that example, sorry, I've not given you a headache by scrolling up and down so fast. We've got the error plus or minus in a bracket, and then outside the bracket we have the unit. Now that's a good way of doing it. So, in a bracket, plus or minus. I'll talk about what the error will be in a minute. And then seconds. There should be some clear delineation between the quantity and the unit. Generally, I think the quantity would be italicised if you were typing this up, and that helps to sort of hold the difference between the two. But it shouldn't. But you shouldn't have the S right here because then it's not really clear what that is. This is all about clarity. Okay, so as for the actual error itself, this is down to your reaction time. So about 0.2 seconds is probably perfectly acceptable. Okay, and then this one is exactly the same set of raw data, so it would all be repeated in there. Unless you had a column that just went across the top and just repeated columns underneath it. That would be perfectly fine. Okay, so for mean t, again we need seconds. So either writing it somewhere else or putting a bit of a delineation. So a good way to do it is /. At A-level physics we'll accept like brackets and things like that, but / is a better way of separating them all. Likewise for time period, S, and for length, this is going to be centimetres. Now if we measure the length of a pendulum, we've also got the error, so this is raw data. So let's say we measure into the nearest millimetre, which you probably should have been. I'm going to say I want to measure this in metres, alright? Which means my error is going to be half a millimetre. Now half a millimetre would be 0.0005 metres. So that could be my error. But is that too small? If we're measuring slightly awkward to measure pendulum, I probably can't say I'm accurate to the nearest half a mil, or plus or minus half a mil. So realistically, I'd probably say 1 mil, maybe even 2, if you were going off a lump of blue tack or something like that. So I'm going to go with 0.001, which is basically a millimetre. Okay. Now I've not put, you'll notice, any errors in t-bar, the mean t, or t, the period. And that's because these are calculated values. So there isn't an error at the top of those. So no error in heading, there, or there. The error would go in the table. So error calculated for each value, because for every value it could be different. Okay, and that's something we're going to look at later. Okay, now just out of interest, if you've got a value in here, so 1.0 seconds, 1.0 seconds, we don't put the unit in there. You could have the plus or minus in there like that, with its error, or you could have another table over here where you write the errors after you've calculated them. And again, if you're thinking of what is the most clear, splitting them up might make it difficult, so if you think about it carefully, you could put those two together, but separate table. You're going to work those out at a very different stage. Probably makes sense to have them in a different column, and that way your times here are not obscured by a load of plus or minuses, and you've got to try and look at it a little bit more carefully to see what the numbers are. So the best way would be an extra column later, but again, just while we're talking about it for now, that's not something I'm going to worry about at this point. Okay, so let's just fill in some numbers. Right, now I've got some just sort of rough modelled data here. So 0.553 metres, so it's correct to the nearest millimetre. If you're working in centimetres, you shouldn't be working to the nearest whole centimetre. So you should have 1 decimal place. If you're working in metres, you should have 3 decimal places. You're definitely going to be measuring to the nearest mil. Unless your ruler doesn't have mils on it, in which case get one. Sorry, but get one. Okay, we then, the times for that one, let's say I've got for those. So 29.9 seconds and let's say 29.7 seconds. Okay. Right. So, oh, I've put seconds in again. Bad me. Right. Now, the stop clock might measure to 2 decimal places. But if my error is plus or minus 0.2, there's kind of not much point having that extra decimal place. So, 1 decimal place is fine. 2 decimal places is essentially, it's too precise for our error. Because although the stop clock measures to the nearest hundredth of a second, the limiting factor on the precision here is our reaction time. Now, there'd be nothing wrong if the stop clock says 2 decimal places and recording 2 decimal places. You're just recording your raw data. There's nothing wrong with that, but you're perfectly justifiable in cutting it down to 1 decimal place. Okay, so let's just fill in a few more of those. So I'm not going to make you watch me do that. I'm just going to I'll pause this on a second and we'll fill it. Okay, so as if by magic, numbers have appeared. Now, a few things just to note about this. So firstly, notice I've started at about ½ metre. Let's say it's about as long as I could get my pendulum to be. And I've started to go down and I thought I'm probably going to run out from going down at about 10 centimetres. So for this one here, I've gone up again. We don't have to collect in order. Right? Some experiments lend themselves to them, but each one of these is a completely distinct trial. So it doesn't have to be in order. The advantages of collecting in order is you can see if you've got a reasonable spread. So there'd be no point doing like 55 centimetres, 54, 53, 52, 25. That'd be a stupid set of data. But provided you know you're getting a reasonable spread of data going through, reasonable intervals, it's fine. Also note it's not going up and bang on 10 centimetres. The first thing everybody does wrong with the results table like this is they put in the lengths first. Oh, I know what I'll do 10, 20, 30, 40, 50. Perfect. Just like we always used to do at school. Okay, well, can you get that pendulum to be exactly 50 centimetres? No. Set it to about 50 and measure what you've got and record what you've actually got. If it isn't exactly 50, 55, whatever. If it goes down by not exactly 10, doesn't matter. It's going on a graph. They don't have to be in a specific place to give us a graph. We just need as good a range as possible and reasonable intervals between them. Okay. So if at one point, I could have got to the end here and realised that by the time I got to the last one, I'd only got 5 points and I should probably do another one. I could have gone back and done the 0.621 right at the end. Wouldn't be a problem. Doesn't matter. Because each of these has its own trial number. So we number these as we go, and I can keep track of which is which. When I work out errors, I'll keep these in the same order and I'll know which error I've worked out. So that's what the trial numbers are for. It's just a code, really. Okay. Now, so some things to notice then. Again, these are all 1 dp, especially that one. So make sure that you've not got anything like that in there. That's 1 dp is 2. 1 dp. Even though it's in 0.0, you've got to have that 0.01. Okay? Right. Now then, we'll go on to looking at calculating things like means and values for t later on. But just for now, so let's say we want 27.9 and 29.9 and 29.7. So 27.9 and oh no, 29.9, and it helps you read out the right numbers. 29.7, okay, divided by 2 gives you, obviously, 29.8. Now that's nice and easy. But if you got one that was 27 and 27.3, divide that by 2, gives you 27.15. Well, it's not really correct to sort of give more precision to this one. We couldn't put a 0 on there and lie about the amount of precision we've got. So we round. This one would be 27.2. And that might make it slightly closer to one of the values than the other, but that's where precision works. That's what rounding errors are. Okay. So then when we get to 10, basically what we're keeping consistent from there to there, so let me do this in a slightly different colour. So these are 1 decimal place going down, but that as a value, these are both 3 significant figures. So when you go into there, this also needs to be 3 significant figures, okay? So when we work out the value of t, that is also going to be 3 significant figures. That's now the limiting factor. All right, so that was 20 oscillations. So if we take our 29.8 and divide it by 20, we get 1.49 seconds for the period. Now, I have gained a decimal place. Doesn't matter because it's 3 significant figures. So the t-bar and the t are to the same level of precision. All right, so as you're going along, it's 3 significant figures all the way. Now, I just want to give you another example. I mean, we haven't got one that's this small, but let's just say we had another reading, which was 9.1 and 9.1 for ease. So the mean would come out at 9.1. This is 2 significant figures. So when we divide 9.1 by 20, and we get, divide by 20, you get 0.455. The time we'd end up getting in there would be actually 0.46, because you round it up. Again, it has to be 2 significant figures. Okay. Now, if that was in the same table, notice we've got 3 significant figures all the way down the table, and this last one is 2. But it's 2 because the raw data it came from was 2. So you don't have to be consistent down a column once you're on calculated data. The significant figures depends on the raw data. The only thing you have to keep consistent is the number of decimal places in raw data, unless for some reason the method by which you're collecting the data changes, but at this level that's something you should be able to completely avoid and definitely should do. Okay, that's it as results tables, for now anyway. So we'll get on to what we do with that in the processing and calculating the errors in that t-bar and t as part of a later lecture.